Hi, it's been a while. Um, and in this video, we're talking about naming of alkenes and specifically naming alkene stereoisomers. So these are two alkene stereoisomers. We talked about how eliminations can lead to exclusively this one or exclusively that one because of the anti-periplanar situation. But while we were able to previously recognize that that molecule is different than this molecule, we were not able to name them in a way that would explain which one was made without drawing it. So that's what we're going to learn here. And it's something called the EZ naming system. It's German, so the Z is Z, and I can't remember what the E is for, but we'll get there. So for EZ naming, so I guess just to start out both of these, we would number this way, and we'd have a 3-methyl. And both of them have 6 carbons in the longest chain, so that'd be hex, and then both of them would be 3-ene. But how are we going to describe one and not the other? That's when we use the EZ naming system. So what we do is we look at the carbons of the alkene and we list the substituents attached to each carbon. So we'll label this A and this B. So carbon A is the first carbon of the alkene. It has a CH2CH3 and a CH3. Carbon B has a CH2CH3 and an H, right? We don't have that one drawn in, but that's an H. So we list those and we prioritize them according to the same RS system, so the largest atom wins. In A, that carbon ties that carbon. These 3 hydrogens are beat by that carbon. So this would be the winner. This would be priority 1, and this would be priority 2. Along the other one, this would be priority 1, this would be priority 2, because a hydrogen is smaller than a carbon. So when we're doing alkenes, we only have 2 different substituents off of them. We'll put those numbers up. We'll put it in a new color. So this would be priority 1, and this would be priority 2, 1, and 2. So we've prioritized them, we've numbered them, and then we're going to draw a line through the alkene. So we drew the line through our alkene, it turns out that if both top priorities, so both of the 1s, are on the same side of the line that we drew, so both of them are on the same side up there of the line that we drew, it's called a Z alkene. Z. I jokingly say that Z stands for those are on the same side. Get it? Like same side, but with Z's. You love it. Yeah. Same side gets Z. So this would technically be Z. And then we have the 3-methyl. And then it's hex, because it's 6 carbons long. Hex 3-ene. So Z 3-methyl hex 3-ene. This is the same one, except for if we draw our dotted line and we note that this is priority 1, this is priority 1. They're on the opposite sides of the line. They're not on the same side. They're on the they're on the opposite sides, which it's the opposite. No, I just made that one up. It's the E alkene. When they're not on the same side, they are labeled E. So this one's the Z alkene. This one would be E 3-methyl, same name as that one. So this stuff right there. So what's the difference between these two? They're stereoisomers. They're diastereomers, actually. And one of them is the Z-alkene. The other one is the E-alkene. So we'll practice this again in another one. See you then.